How's it going, everybody? And thanks for stopping by our Cisco iOS Basics series. In this video, what we're going to be taking a look at doing is a slight variation to what we did in the IPv4 static routing, where we did a telnet connection from R4 right here to the iNet router. Well, we did it via telnet, and telnet is just not secure, right? And telnet doesn't require a whole lot other than a username to be created globally, and then you need to go underneath the VTY line to allow the transport of telnet inbound, and so that the VTY line can point to the local database for authentication. Pretty straightforward stuff, doesn't really require a whole lot of effort on our part. Well, the one thing we definitely don't want to be using when we're traversing any type of transport where we're not sure what's going to be seen and what's not going to be seen, we definitely want to be using a secure connection to basically protect any of the passwords. Because if I was to do a Wireshark capture or take a look at the data path, the data plane of the telnet connection, the username and password is actually passed in clear text. So that's not something we would definitely want somebody that we don't want accessing network devices to know about. So what we're going to go do is enable SSH on the iNet router for the simple aspect of providing connectivity securely to the iNet router. We're going to go through those steps right now. So configuration wise, it's actually really simple. So let's go ahead and pull up the iNet router, and then we'll do an SSH test from router 4. So what I'm going to do on the iNet router, the very first thing we have to do on the iNet router, which has already actually been done, is you have to create a unique host name. Okay, iNet router, iNet is the host name. We are good to go there. So the host name first has to be configured. After the host name is configured, the next thing we have to type in is the domain name. So we're typing IP domain-name is going to be sn.com. So we have sn.com, simplifiednetworking.com. Everything is good to go there. So that's squared away. The next step that we have to go through is we have to go through and create a crypto key. So we're typing crypto key, and we'll say generate an RSA key. And the RSA key that we're going to be using is going to be what they call a general key. So we'll type in general key. We're going to specify that the modulus on the key is going to be 1024. And we're going to label it. Now I'm going to give it SSH, and then I'm going to hit the enter key. There's some other options that we can do, like we can allow the key to be exportable for doing different things down the road that we might test out. And we can also specify the storage. We're not going to really mess with that. We're just going to go ahead and configure this. Now, one thing to take note that I want to point out is the reason why the modulus is 1024 is because in order to enable SSH version 2, which is the common methodology that we're going to be using today, or in today's networking, I should say, is that in order to enable SSH version 2, you need to have a key size of 768 bits or higher. So anything above 768, you're going to enable SSH version 2. So I'm going to go ahead and hit the enter key, and it says that the key module size was created and generating 1024-bit RSA key. The keys will not be exportable. Now it says SSH enabled. SSH 1.99 has been enabled. I see a lot of people having a hard time understanding this logic. It doesn't say SSH version 2. It says SSH 1.99. 1.99 enables both SSH version 2 and SSH version 1. So it's backwards compatible with both. So there's that. So now if we go in here to show IP SSH, we're going to see that we have version 1.99, and we can see what the different capabilities are. For example, we can see the public key algorithms that are being used, SSH RSA, and then we have the host key algorithms that are being used. The encryption algorithms that are going to be used or negotiated in the SSH connection are these guys. We have the hashing algorithms, HMAC SHA-1, HMAC SHA-196 bits, or 196, excuse me, because this is 128. This is 196. And then we have the timeout value, how many retries there are going to be, so on and so forth. Now, what I'm going to go do is on the R4 device, I'm going to come in here and type in SSH and I have to specify a username. So I'll type in -L. Actually, if I come in here, there is to be some options that we'll have to use. I'll type in -L for the username, which will be Rob, and I have to specify that first, and then I can type in 102.0.0.1. By typing that in, that'll send the connection out to the iNet router, and after a moment or so, there it pops up, and we're going to go ahead and type in Cisco, and there we're connected. If we do a show, and notice how it's much slower, show SSH, we're going to see that we have an active connection. We have a no SSH version 1 server connections running, so we're running version 2. We can see that we're using AES 128 CTR HMAC SHA-1. The session started. The username is Rob. So we have a connection going in and a connection going out. This is going to be the secure connectivity that I was talking about. If I do a show users, it is a little bit it's a little bit slower because of the fact that we're now using encryption, and that's causing the CPU on the router to kick in and work, and we can see that we're connected the way that we were in the telnet, or when we can tested telnet in the IPv4 static routing video. So with that being said, ladies and gentlemen, that's how you enable SSH on an iOS router. The same process would go for an iOS switch and stuff like that. So until next time, guys, thanks so much for stopping by, and take it easy.